Okay, we're on a baseball diamond. The batter is looking at the second baseman, who's this distance away from second base, and this angle right here is 14 degrees, and you're supposed to find out what this distance is right here. How far is the second baseman from second base? There's a couple things you need to know. First of all, they call this a baseball diamond, but it really is just a square, 90 by 90 by 90. And if you draw a diagonal from one vertex to another, since it's a 45-45 right triangle, that hypotenuse is 90 radical 2. It's a 45-45 90 right triangle, where the hypotenuse is radical 2 times one of the legs. Okay. Now, once you've got that, there's a couple ways to do this problem. First way is to realize that this is a 45-degree angle. So if this angle right here is 14, this has to be 31. And now, if this distance is x, this distance is 90 minus x. So one way to solve the problem is to picture this triangle right here. We've got a 31-degree acute angle. This distance is 90 minus x. This distance is 90. We can use the tangent ratio to solve for x. The tangent of 31 equals opposite over adjacent, 90 minus x over 90. If you solve for x by multiplying both sides by 90 and then solving for x, this is what you get. And we'll see what that evaluates to shortly. The other way to do it is to use the law of sines. Picture this triangle right here. I'll go to green. It's this triangle right here. So I've redrawn that over here. There's the side labeled x right here. This is the diagonal of the square. This is 14 degrees. If this was 14 degrees right here, and we know this is 45 degrees. By the way, I didn't mention that this is a rhombus, so diagonals of a rhombus bisect the angles at each vertex. But that leaves 121 degrees for this angle right here. And so we can use the law of sines. We know two angles and one of the sides. So x is to the sine of 14 as 90 radical 2 is to the sine of its opposite angle, 121. Solving for x gives us this expression right here. Looks like two very different forms for the answer, but if you do a decimal approximation, there's 90 minus 90 tangent 31, 35.92, and there's 90 radical 2 times the sine of 14, divided by the sine of 121, same thing. Okay, so that's the distance the second baseman is from second base right there. There you go. Hope that helped. I know this problem was posted a long time ago, but stumbled across it. Thought I'd give it an answer. If you do have any questions, see this solution, go ahead and post a comment.